So, Newton's three laws. Did you do it?
What? It's me.
It's Ming.
Yeah.
What's wrong with her?
Hello?
Oh my goodness.
Hello?
Yeah, I saw her heading the wrong way.
We're in Cav. C-A-V, Cav.
CAB. CAB.
Where's she?
Wrong class.
Oh, Ming. Oh dear. Right. Homework. What do we need to see from? Yeah. What was number 2 about? Okay, let's have a look. Let me open it. Yeah, I pressed the power button and I can see there's, and it is connected. Maybe I have to press the switcher button. There we go. Here we go. But it's off center. I'll fix that now. Oh my goodness, come on. Okay. What's the ID number on that one, Marwan? 72? There we go. Perfect. Okay. ID 72. Let's have a look. No, not that. $72. Okay, let's zoom in. Oh, with the, yeah. A lift of mass 560 holds 3 people of a combined mass 215. Assume the lift is lowered and then raised by a single support and that you can ignore the friction. What's the tension in the cable supporting the lift when it is stationary? Okay, so, which,
Sorry,
yeah?
Last class was not a revision class.
The last class
Friday.
for what? Physics or maths?
Physics.
No. Oh, maybe I know what you're asking me. So for physics, it's not like maths. For maths, I have 1 class a week for revision, and then with physics, we do any problems with the homework at the start of the next class. So that's why I'm asking, was there any problems with Newton's three laws? That's all we did last time, wasn't it? Yeah, and before that was projectiles, isn't it? And we did all the questions on projectiles. Yeah. So Newton's three laws now. So which law gives us the answer for part 1 here? No, not for part 1. Which room did you go to? Oh, Ming, that was the wrong room. Which law gives us, guys, you're looking at me like you're brain dead. I know it's Monday morning. The first law, because the object is stationary, so the tension must equal the weight, which must equal mg, which must equal 215, is it? 9.81. Oh, does the elevator? Oh yeah, the elevator has a mass, doesn't it? 215, of course it does. 215 plus 56, 9.81. So 4 significant figures, what do you get here, please? 776,000.
No, 76000.
76000. Yeah?
No, 20.
2 zeros. Yeah? Okay. Part 2. Determine the tension in the cable when the lift is moving upwards. So when the lift is moving up, the tension is bigger. You have F equals T minus W equals MA. So T equals W plus MA, which equals 7600 plus 560 plus 215 A. And the A is 0.56. Okay. What you got here? 8040. Yeah? Newtons. Okay? And the only difference for part 3, what's the only difference for part 3? What's the only difference for part 3? Huh? Downward, yeah, so how does that change here? No? Yeah. Well, yeah, the only difference... Oh, wait, when you say weight is bigger, give me the full sentence. Bigger than what? Yeah, that's it, okay. The weight is bigger than the tension, yeah. Sorry, I thought you were saying the weight was bigger than previously. Or maybe it's more accurate to say that the tension is smaller now. So, what changes here is the formula. Instead of being T minus W, it's W minus T. Isn't it? Because it's going the other way. The W is bigger than the T. Yeah? So, in fact, a sneaky way you could do part 3 is you just have to change the signs. So that would be a minus, and that would become a plus. So that means T, instead of being W plus MA, would be W minus MA. So I'll just do a comma here. Instead, if you just go back on the calculator and change a plus to a minus, you can quickly get the next answer without having to redo everything.
Doesn't it say plus the 3 and acceleration 0?
Oh, thank you. Thank you. I misread it. It says, I thought it said at the same acceleration. Determine the tension in the cable when the lift is moving downward at a constant speed. Alright, so that's even quicker. What law do we need for this one? Yeah, so what's the answer for part 3?
Same as part 1.
Very good. Very good. Same as 7600 newtons. In part 1, this was stationary. In part 2, this is moving at a constant speed. And Newton's first law says that an object will remain at rest or in constant motion when there's no net force acting on it. Yeah? Yes? How many questions did you have to do in this one? 2. And did you do both of them? What was the first one about? I'm not 100% convinced you're doing your homework, so I wanted to see everybody's question 1. So take out your question 1 for me. Yeah, let me see question 1. Oh my goodness. Yes, you're a lot of trouble this morning, Ming. A lot of trouble. Right, you got your question 1?
I was in class.
But did you watch the video? You see, so you're behind this lesson. You had the weekend to catch up on it, you know? Okay. Worked out okay? Got question 1 there? Worked out okay? Alright. You got question 1?
No.
You have 1 question or 2 questions to do for homework and you decide to do 0. So what's the deal with that?
No.
Now, just be careful, you can make things much worse if you give me a stupid answer. So what's the reason? That 2 days, do 2 questions. 24 hours per question, not enough?
I have to go and see my people personal.
Okay, okay. I'm not entirely satisfied with that. Question, you got it? Ah, this is terrible. Got question 1? Yep. You got question 1?
Everything's question. I have math homework.
Oh, good. Okay, you have it in a notebook. You got question 1, Marwan? Was okay? You got question 1 there? Yeah. All right. So I assume we can go on to the next lesson then, since there was only 2 questions then. Yeah? Okay. Did I? No, I didn't check the middle, did I?
You did?
I did? Oh yeah, I did. Well, I'll check it again because I forgot. Question 1? Question 1? And question 1. Nice. Okay. You guys are forgettable. All right. Let's continue. Ugh.